Oh, well, I have had quite a week. From a broken tooth to temporary crown, um, to a daughter who gashed her foot open with a mason jar, to finding out that this practice midterm was set up with the date on the 20th where it opened and then also closed on the 20th. So I'm pretty sure, well, I saw that no one had gotten in and tried the practice exam. So I have had this open since I saw that mistake, which was earlier this morning. I hope that some of you guys have gotten in and had a chance to practice the midterm. But I thought I'd do some things to kind of kickstart your study on the midterm. Again, the actual midterm for in class with me will be on the 24th. That's this Tuesday. Whereas if you're having it proctored, we'll be setting it up with the arrangements that we make with your proctor. Okay, so I'll go ahead and click on this here. Now there's no password and there are 30 questions to practice here. The actual midterm will only have 25 questions. Um, I'm not saying that if you get 100% on the midterm, you're definitely going to get 100% on the practice midterm. You'll definitely get 100% on the real midterm, but I think it's going to come pretty close to that. If you take this practice midterm as a real test, and you can get 100 on it here, then I don't see why you wouldn't get an A on the real midterm. So, what is a voluntary response sample? This comes from chapter 1 when we were originally talking about voluntary response sampling and all the other samplings, convenience sampling, systematic sampling, cluster, stratified, and where we started to nail down that we really wanted random sampling and most especially simple random sampling, and there was a great animation on the difference between random and simple random. Mostly you want to remember that simple random means that that any group of size n, like size 5, has just as much of a random chance of being picked in as any other group of size n, for example, size 5. So they did the tennis racket example. If you go back to the animations, it's a good one to remember. So going back, chapter 1, what's a response sample? A response sample is when you sample and you allow the subjects themselves to decide whether or not they're going to be included in the study. So that's C right here. I'm not going to go through all the non-answers, but you can pause this and look at those if you'd like. On this question, pause it and read through the question just for a second. Okay, so it should be pretty clear. A certain medical organization tends to oppose the use of meat and dairy, largely probably because those are used by animals, right? Or maybe they oppose other animal-related production industries. But you notice that that organization has received hundreds of thousands of dollars in funding from an animal rights foundation. It's a little suspicious, and so we think that might be able to create a bias if you're doing a statistical study with that funding group. So we would say there does appear to be a potential to create bias, and that is because there's an incentive to produce results that will line up with the organization's creed from the funders. You don't want to displease where the money comes from, right? So usually you just don't want to have a study that comes that way, that is formed under those circumstances. Okay, number 3. Does this appear to be sound or flawed? Go ahead and give it a read. Let me pause and read it for myself. Okay, there's probably lots of things you could read into this problem to decide that it is flawed, and I agree it is flawed. But let's look at the choices given, and then maybe I'll talk about things that you might read into it later. Okay, it is flawed. Okay, that's kind of in agreement with what I would say, because it is not statistically significant. What? I think they're implying that this sample size is too small, and that is not a small sample size. In fact, if you were to do a national survey, you could, if you sampled well, you could do a national survey with 1,500 randomly sampled students, randomly sampled subjects, which is really, just more than double this. And that's pretty good. We're talking about the United States of America. That's a pretty huge group. We'll talk more about how you can use such a small sample size to randomly to determine information about population parameter in chapter 7 when we reverse the calculation from our confidence intervals. But we'll get to that then. But anyways, I would agree that it's not, I would say that it's not this first one because this is a statistically significant size. It appears to be sound because the data are not biased in any way. Well, I would agree with that if I didn't think they're biased, but I'm going to read on because I think they are. It's flawed, okay, I agree. Is it because it's a census? First of all, if it was a census, it wouldn't be flawed because a census would mean that you were able to ask every single, I'm assuming our population here is TV watchers, every single TV watcher. If that's our population, a census would have been taking information from all of them, surveying all of them. And we didn't, we used a subset. See, here's our sample of 684 subjects. So how about the last one? It is flawed because it's a voluntary response sample. Now, we talked about voluntary response sample as we reviewed number 1, but remember the problem is that because they're choosing if they're going to be subjects or not by the way that they respond, then there's a bias to those that are more, well, there's a bias that can be had in different ways. There's the famous one from the Literary Digest that did the polling for the Truman and Dewey presidential campaign, and they had asked their readers, but their readers were all biased to one political party, so they were the ones that responded in high volume, and they made it look like that there was going to be a hands down win for I think Dewey, and ultimately it was the flaw in their response in their survey that it had a voluntary response bias. That's what we have here. The survey subjects were internet users, which first of all might not even be targeting the population we want, right? Because we're talking about probably broadcast TV watchers right here. These are internet users that might be part of a dichotomy, a separate group of people here that are watching some news website and they find this poll. But they decide if they're going to participate or not, and that's the voluntary response part. There could be other things wrong with this. The fact that it's not really coming out of your population. So, voluntary response, I'd go with that. I think we have time for one more in this group of questions. I don't want these to go too long. In a study of a weight loss program, 40 subjects lost an average or mean, arithmetic mean is what they mean there, an average of 3.3 pounds after 12 months. Whew. Think about that. Methods of statistics can be used to show that if the diet had no effect, if it was non-effective, the likelihood of getting those kind of results, right, the ones that we just described, is roughly 10 chances in 1,000. That is tiny, right? Look at the decimal value of it. So that's 10 in 1,000. That's 10 1,000th. Or in other words, let me get that down again. In other words, 1/100th, right? 1% still. Less than our typical benchmark 5% we've been using for the level of statistical significance. And I point that out because we're going to ask, does the weight loss program have statistical significance? No. Right? Because if it had statistical significance, we would say, you know, it was good. So let's read the question here. Does the weight loss program have statistical significance? Oh, I'm sorry. Let me read that carefully. The result of this happening by chance was very small. And what we're saying happening by chance was that the diet had no effect. So we should be saying, yes, that it has effect because it wouldn't have happened by chance. So yes, because the results are unlikely to occur by chance. That's C. Then the rest of the question, does the weight loss program have practical significance? So it does have statistical significance, assuming that, you know, methods of statistics were done to show that. But does it have practical? No. Because in 12 months, you would expect to lose more than 3.3 pounds. So it doesn't seem to be providing much value. And I could kind of go either A or C. No, the results have a chance to occur even if the weight loss program had no effect. Well, no, not really. Actually, I won't go with A at all. Because they said they'd already run some statistics on it, and that if there was no effect, the only chance of that happening was 10 in 1,000 times. So really, the only choice we have here is C. No, someone starting a weight loss program would likely want to lose considerably more than 3.3 pounds. So it's not practically very useful. But statistically, yeah, technically, apparently we've done a program here that works. Now get that program to do more than that. Okay, I'm going to save number 5. I'll start with number 5 for another... Wait a minute. Hold on. I know it's going long here, but let me go ahead and nail this down. And then I'll grade it, see if we got the first 5 here right, and then I'll do another set of these in a separate video. Okay, what is the difference between a random sample and a simple random? I'm going to go ahead and cheat, which you should not be doing during a quiz, but I want to show you an animation here. So you know what? I looked around and I realized that, and I looked in the multimedia library. In fact, I'll show you that again, what I had done. I went ahead and hit all animations. It used to be in the first or second chapter, and it was an example called How Random is Random, which described the difference between simple random and just random sampling. It's the simple random sampling that matters so much, and the animation was great. I don't know why they took it out, so I went and fished it out of an old version of this textbook, and now I've put it in here under the Tools for Success, where it was talking about animated flowcharts. Well, I mean, it still talks about animated flowcharts, and then beneath that now I've added this whole piece about with the animation about how random is random and other types of statistical studies. So you might want to check that out. I highly suggest it. I'm not going to take the time, so kind of make it as homework in addition to what this is doing. Okay, and now my test time has run out while I was doing that. So I'll go back to this number 5. This is the one I was answering, and I'll make the next set of questions from 6 and however far I get after that. What's the difference between a random sample and a simple random sample? And here's the definition. It's with a random sample, each individual has the same chance of being selected. With a simple random sample, not only does each individual have a chance of being selected, but groups, samples of size n, whatever you want it to be, have the same chance of being selected. You really, to understand that, it seems like such a simple thing there, but to really understand it, you should watch this How Random is Random in the Tools for Success. Alright, this video has gone on longer than I wanted. The others will be shorter. Thanks.